Welcome to this video on factoring polynomials when the a value is greater than 1. By the end of this video, you should be able to factor out a GCF and then completely factor a remaining polynomial. You should also be able to factor a polynomial whose a value equals 1 and a polynomial whose a value is greater than 1. Alright, so let's take a look and let's try these top three. So these are what we've been doing where we had the a value of 1 and let's try factoring. So remember, we're looking for what multiplies to 6 but adds to 5. So it's a positive 6, so it's either a positive number and a positive number or a negative number and a negative number. Because the 5 is positive, it's going to have to be two positive values. So we have 1 and 6 and 2 and 3 are our only choices. If they both have to be positive, 1 and 6 won't work, but 2 and 3 will. So we take our factor pair and we write them as the binomial. We could check our work by multiplying those back together. These are equivalent expressions, they're just written differently. Remember, this is what we call factored form. Alright, let's try the second one. So the second one, our a value is not 1, but when I look, I notice that there's a GCF. All three of these terms have a 2 in common. They don't all have an x, so they cannot have the x in common. So I'm going to write the 2, and then what's left over would be x squared plus x minus 12. Okay, now I need to see if I can factor this again. So I'm looking what multiplies to a negative 12 but adds to a positive 1. Because it's a negative number, that means one of the factors is a positive and the other one is a negative. So for 12, we have 1 times 12, 2 times 6, and 3 times 4. So 3 and 4 are are one apart from each other. Now I need it to be a positive 1, so that means I need the 4 to be positive and the 3 to be the negative, because negative 3 plus 4 is positive 1. Or you could look at it the other way, 4 minus 3 is positive 1. So that's my factor pair that I want to use. Don't forget to bring your GCF. He's part of the problem because it has to multiply back to where we started. And we're going to have x minus 3 times x plus 4. All right. And let's take a look at this last one. So our a value is not 1, so we need to look for a GCF. 5, 17, and 6. There's no value that goes into all of those that's the same. And they don't all have an x, so there's no GCF here. Well, let's give this a try. Are there multiples of 6 that add to negative 17? So that means they either are both positive, because 6 is a positive number, or both negative. 17 is negative, so it'd have to be negative, negative. So we have 1 times 6 and 2 times 3. Well, none of those work. If I do negative, negative, that'd be negative 5. Or negative 7, not negative 17. I have no GCF, and I have no factor pair that works. So you might think, well, I just can't factor this one. Well, there's a special way to factor these. If you take out your GCF, like we did here, if your a value is 1, we can factor what we've been doing. If you do not have a GCF and your a value is something other than 1, well, that's what we're going to learn today, is how to handle that. So take a look here. So when our a value is greater than 1, so we're talking about that after we take out our GCF, because you will always check for GCF before beginning any problem, okay? If the a value is greater than 1, you will need to multiply a times c and then find the factors of that new number that add to b. So it's a little bit of an extra step. So here's what I'm talking about. This is the exact same problem from right up here. So this is my A value, this is my B value, this is my C value. Okay, if I take A times C, I'll get 5 times 6, which is 30. That's a positive number, so either both my factors will be positive or both my factors will be negative. It's a negative 17, so it's going to have to be negative, negative. That's the only thing that's going to make that work. So let's look at 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. These are my factor pairs that make up 30. If I'm going to have two negatives, and they need to go to negative 17, the only thing that will work is if we use negative 2, negative 15. Okay, so the first thing I want you to do is I want you to take this factor pair, and I want you to substitute it in for negative 17x. So you're going to substitute negative 2 and negative 15 in for negative 17. Okay, so 17 has an x on it, so here's what we're going to do. We're going to write 5x squared minus 2x minus 15x. Now when I look at that, negative 2x minus 15x is negative 17x. I haven't changed the value, I just made it look different. And then we have plus 6 off the end. Okay, once you've done that, what I want you to do is break this into two groups of 2. 4 numbers is a lot to deal with, so we're going to make it into 2 smaller problems of 2. And so here's what I mean. Right here, after the x but before the minus sign, break it in half. So now I have a left-hand problem and I have a right-hand problem. From here, we're going to find the GCF. So let's factor out the GCF from both sides. Okay, so let's look at the left side. 5 and 2 do not have a number in common, so they have no number in common, but they do both have an x. They have a single x in common. So they have a GCF of x, and what will be left over is 5x minus 2, because these x's will cancel. So that's the left-hand problem. Let's go look at the right-hand problem. So in the right-hand problem, my first term is negative. Remember, if your leading coefficient is negative, you got to divide, whatever you divide by has to be a negative number. So I know I'm going to have a negative number here. So 6 and 15 both have a 3 in common. So we're going to divide both sides by negative 3. So just like before, I'm going to take that negative 3 and I'm going to write it in line with the rest of my problem. That's my GCF. And let's see what's left over. Negative 15 divided by negative 3 is 5. And then the x comes down because he has got nobody to cancel with. Then I have a positive 6 divided by a negative 3 is negative 2. And I'm at the end of the problem. You know you are right and you've done everything perfect up until this point when these two parentheses match. Okay? Now, I have two terms. This is the left term, I have the right term. What we want to do is we're going to factor out the common binomial. And once you do that, you're going to have two things left over. You're going to write what is left over in its own parenthesis. Okay, so here's what I mean. They both terms have a 5x minus 2. That is their common factor. So I'm going to divide this side by 5x minus 2. And I'm going to divide this side by 5x minus 2. And what happens, that's my GCF, so we always write the GCF out front. This cancels with this, leaving an x. This cancels with this, leaving an x minus 3, and it says write what is left over in its own parenthesis. So in the other parenthesis, x minus 3. Now we're in factored form. We could multiply this back together, and we would end up right back up here where we started. All right, let's try this again. So let's take a look at number 1 right here. Remember, to start this, we got to check for GCF first. So on the numbers, I have 3, 11, and 10. They have nothing in common. Only 2 of them have variables, so there's no variable in common. So the first thing I need to do is remember to do a times c, because my a value is more than 1. So 3 times 10 is 30, and this is a positive number. That means both of my factors are either positive or both of my factors are negative. I'm trying to get them to add to negative 11. That means both of my factors will be negative. So I have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So I'm looking for negative 11. The only thing that's going to work to get me to negative 11 is if I use a negative 5 and a negative 6. This is going to be my factor pair. I'm going to substitute that in. So instead of a negative 11 squared, 11a, I'm going to break this up a little bit. So I'm going to say 3a squared minus 5a minus 6a plus 10. 5a minus 5a minus 6a is negative 11. We just split it up. Now I'm going to split the whole thing. I'm going to put 2 on the left and 2 on the right. Be sure you're breaking it between the variable and the sign for the second half. So when I look at the left-hand side, 3 and 5 have no numbers in common, but they do both have an a variable and they share a single a. So when I take my GCF out, I write it up front, and what's left over is 3a, because one of the a's cancel, and minus 5, because both of those a's cancel. Okay, now when I look at my second half, I see that my leading coefficient is negative. That means no matter what I divide by, it's got to be a negative number. Okay, 6 and 10 have a 2 in common. They have no variables in common, just a negative 2. So you bring your GCF down, you write it in front. Negative 6 divided by negative 2 is a positive 3, and the a has nowhere to go, so it comes along with. Positive 10 divided by negative 2 is negative 5. Now I have the same parentheses here. Factor out the common binomial. So the common binomial is 3a minus 5. And what is left over, that because these would cancel if we did the longer math like we did up here, is a minus 2, and that will go in the other parenthesis. All right, let's try another one on the front, and then we'll flip to the back. Let's try number 4. So number 4, I look for a GCF. There's no GCF on variables or numbers, so I got to go to where I got to find my factor pairs. Because a is greater than 1, I have to do the a times c, which gives me 4 times 1, which is a positive 4. That means my signs are either both positive or both negative. My middle term is negative, so that means I need to use the negative signs. So I got 1 times 4, 2 times 2, and to get to negative 4, I would have to use negative 2, negative 2. We're going to substitute those in. So we have 4a squared minus 2a, then the other factor pair, minus 2a plus 1. Okay. 4 is too many terms to deal with at all at once when we're factoring, so we're going to split it to make it a little bit easier. We're going to look at just the right-hand side. 4a squared and negative 2a, they both have a 2 in common. and they both have an a in common. So we have a GCF of 2a, and let's see what's left over. 4 divided by 2 is 2. A squared divided by a is a. And then negative 2a divided by 2a is negative 1. Okay, let's look at our second half. That leading coefficient is negative again, so no matter what I divide by, it's going to have to be negative. 2 and 1 have nothing in common, and they don't both have a variable. If there's nothing that they share in common, you can always pull out a 1. This one just happens to be a negative 1. So our negative 1 is our GCF, so he goes out in front, and what's left over is negative 2 divided by negative 1 is a positive 2, and then we have our a. And then you have positive 1 divided by negative 1 is negative 1. Factor out your common binomial, which is 2a minus 1, which would make these cancel. What is left over goes in the other parenthesis. Okay, these happen to be the same term, so usually how you're going to see these written is just like that. All right, let's flip this over and try the other side. Okay, so sometimes even these a is greater than 1 problems have a GCF. We're always going to check for GCF first, so let's see what that would look like. Let's look at number 5. So we have 10, 75, and 35. They're all divisible by 5. They don't share a variable because only 2 of the terms have a variable. So let's take out our GCF of 5. Remember, write your GCF out front, and what's left over is 2a squared plus 75 divided by 5 is 15. A 35 divided by 5 is 7. So now you notice this a value is still greater than 1. So what we want to do is we got to do the a times c. So 2 times 7 is 14. So it could, our signs of our factors have to be positive, positive, or negative, negative. When I look at my b value, because it's positive, my factor terms will also be positive. So to find factors of 14, they're 1 times 14 and 2 times 7. Those are my only choices. So if I have 2 positive numbers, if I want to get 15, I have to do 14 and 1. So this GCF, what I'm going to do is, we don't want to lose them along the way. I'm just going to put them down here where I'm going to write my answer. Okay. From here, it's really the same thing. We're going to substitute in 2a squared plus a plus 14a plus 7. I just substituted in because a plus 14a is 15a. You want to split these right down the middle. Okay. Let's look at the left-hand side. There's no number in common, but they do have an a in common. So I'm going to take out my GCF. And what's left is 2a, and then a divided by a is 1. Then when I look at my right-hand side, I have a positive there, so my leading coefficient is positive, so I'm going to divide by a positive number. And 14 and 7 have a 7 in common. They do not have a variable in common. So that's a positive 7 that I divided by. And then 14 divided by 7 is 2, and the a comes along. 7 divided by 7 is a 1. Okay. We have a common parenthesis here. We're going to remove that for 2a plus 1. What's left over when these got factored out is a plus 7. Okay. You can't forget that GCF, because when we multiply all this back together, it needs to start back where we were at the very, very beginning. All right, guys, let's do one last problem, and then when you come into class, we'll review some of these. So check for GCF. We have 8, 8, and 2. So I know they have a 2 in common. They do not have a variable in common because only 2 of these have a variable on them, so not all 3 of them do. So we have a GCF of 2, and we're left behind with 4a squared minus 4a plus 1. Okay, my a value is still greater than 1, so that tells me I've got to do a times c. 4 times 1 is a positive 4. Remember, if it's positive, the signs are the same. My b value is negative, so that means I'm looking for two negative factors to make this work for me. So 4 is 1 times 4, or 2 times 2. If I'm going to get it to be negative 4 in the middle, I have to do negative 2, negative 2. I'm going to bring my GCF down to where I'm going to write my answer so I don't have to worry about him, so I don't lose them. Let's substitute in our 2's. 4a squared minus 2a minus 2a plus 1. Negative 2a minus 2a is negative 4a. I've just separated it out some. We're going to split it down the middle. On the left-hand side, I'm looking for a GCF. 4 and 2 both have a 2 in common, and they have a single a in common. So my GCF on the left is 2a. And what is left over is 4 divided by 2 is 2. A squared divided by a is just a. Negative 2a divided by 2a is negative 1. Let's try the right-hand side. Negative 2 and 1 have nothing in common, and they don't have a variable in common. So that means you can always pull out a 1 when we're doing this, but it has to be a negative 1 because the leading coefficient is negative. So our GCF is negative 1. So negative 2 divided by negative 1 is positive 2. The a comes along because it's got nobody to cancel with. Positive 1 divided by negative 1 is negative 1. Okay, factor out your common binomial, which is 2a minus 1. And what's left over is 2a minus 1. Okay, so probably how you would see this written, you probably won't see it written just like that because these are exactly the same. You'll probably see it as 2a minus 1 squared. Okay, just remember if you take a GCF out, it needs to be part of your final answer. Okay, hopefully this was helpful. We'll go over some of these in class. I'll see you there.